In this video, we're going to create a reusable health component that we can add on different objects in our scene and give health to whatever we want. We're also going to talk about event dispatchers and how we can use them to minimize our dependencies and keep our component as generic as possible. By the end of this video, we will create a damage system inside of a component that we can use to apply damage to different things in our level. So example right here, we're applying damage to our player. We can see it represented on a health bar. We can also apply damage to things in our scene. See, our couch had some amount of health, and then when it ran out of health, it was destroyed. The cool thing about it is because it is inside of a component, we can add common functionality inside of our component, allow our designers to customize things like sounds or health or whatever. Anytime we apply it to an actor, we can customize it individually right there. But we are also using events to let other things know when we took damage or when we were killed, so that we keep it as generic as possible, and other things can watch the events and respond however they want to. So in this case, our player can look and see when our system and look and see when our health system said it was killed and then respond any way it wants. So it's a very simple but modular system, and we'll learn how to put it together. All right, let's build a modular health system. I'm going to keep working inside of my first person game that I've already been building in, but you could do this from any project. It should be a modular component. So we're going to open this up. You can see I already have a lot of other things. We're not really going to use any of it though. So I have a folder over here for components where I'm making all of my custom components. Let's make a new one called, let me do blueprint class. Because our component is only functionality, we want an actor component. If we had other three-dimensional kind of things, we would use scene component, but we don't. So we'll do actor component. It's just health. Tracking values. We'll do BP _ health system component. Control S to save, and let's attach this to our player. Now, I'm going to be working from this first person player character over here that comes in the default template project inside of Unreal. You could attach this to any other character you want. Pretty much anything you want to have health in your game, this should work. But we're going to open this up and we are going to attach the component that we just made. So add BP health system. So this is on my first person character. So we have our health system, we have it attached. Let's compile, save, and now we can start to define it. All right, so let's open up our health component. So over here, this health system component, and let's start to think about what we want. It's always good to have a general plan before you start coding, and then later on we can always build or change or whatever we need, but we want a basic plan. So when it comes to functions, I like to think about the kinds of verbs that I want this thing to be able to do. So for example, take damage, that's something that I might want my health system to do. Kill might be another thing I want it to do. So if I attach this to the player, we can tell the health system to kill the player. And my nouns might be the different kinds of data that I want this class to hold on to. So max health, current health, any other thing that it needs. So verbs, nouns, and the last thing we'll talk about are the event dispatchers, which we'll get to in a second. So in terms of verbs, I'm going to keep this really simple at first. We'll say take damage. All right, and in order to take damage, your function should ask a question if it needs to know information. For example, how much damage to take? We want to request that the other thing that calls this give us an amount of damage to take. We don't want to define this on the component because then we're always only taking 5 damage or whatever you put in there. We want to require that they send that. So to do that, we're going to create a input, select your take damage function, hit the plus button. The input I want is amount, and this is going to be a float. All right, let's compile, save. And the other one we wanted was kill. So let's add another plus on our functions, call this kill. This one, we don't really need to know anything, just kill the object that you're attached to. We can either keep this generic or we can have some basic functionality. Honestly, I haven't decided yet, so we'll compile, save. And then my variables are going to be my nouns. What are the different values that my class needs to know about? So for example, I think a good starting one is health. Our health system should probably know about our health. This is our current health. Let's change this to float. And then also we want a max health. There might even be other things that you want your health system to have. You can always expand this. I'm going to show you the simplest version just for the demo. And let's turn on the instance editable because we want different things that use our health system to define different kinds of max health. I'm just going to set my health to my max health and begin. You don't have to do that either. You could have like a starting health if you want it to be different. You can always customize this later. Let's compile and save. And now I want to set my default values. I think for health, it's fine to put the 0 if we're going to auto default it, but let's just hard code it in just in case. Max health, we'll put that at 100. And then our current health, we're just going to automatically set it to the max health, but you could put a different value here if you want. Compile, save. I think we're good so far. Now, the last thing is event dispatchers. Now, one of the things that I want to do with this video is show how we can use events to send out notifications that other things can hook into so that we avoid our health system being dependent on outside things, even though outside things might be dependent on our health system. This is called a one-way dependency. And it's much better than a two-way dependency. It's very, very handy, helps us keep our health system generic because other things are watching events that we just call on our health system. We don't know what's watching. We're just saying we took damage or saying the thing was killed or whatever. But we're not really watching the things that are responding to it. So it's very, very handy for generic functionality. Let's set it up. So the way to think about this is what are the things that happen that we want to notify other objects about? For example, I might just have one called OnTookDamage. So when we take damage, we can do our functionality, but in addition, send out a notification, anything else that cares that we took damage, and they can respond. Another one I might want is OnKilled. You'll notice here that I'm using the past tense of these things that happen. This is usually because we want to perform our internal functionality and then send out the notification. So usually we're referring to this thing as already having happened, but it's just a good way in code to make that a little bit more clear. So I always like to use past tense and then the on right before, just so it's very clear that this is a event dispatcher that we're responding to and not a function or something else. Okay, you'll see that if you try to double click it, it's going to go in and say read only and all that. We don't really have to go in and do anything here. So if you double clicked it, don't worry about that. We're not really going to do anything. We're just going to call these two event dispatchers when it makes sense in our code once we start adding the functionality. So this is our basic plan, and then we can start to fill in all the different functions and variables that we need, and maybe we'll add more. We'll just find out as we go. All right, so before we start adding our functionality, there is one thing I wanted to show you that's important to understand before we start dealing with damage and health. Unreal has its own built-in damage system that we can build on top of or we can utilize. It can get pretty deep if you want it to be. Like we already have some functions for applying different kinds of damage, a radius with different kinds of damage and so forth. It might be worth reading through some of this if you want to go deep down the damage rabbit hole, but all I really need you to understand is that we have the ability to apply damage to actors in our scene by default, like that just comes with Unreal. But if we want to do anything with it, like track health and detect whether or not we've died or anything like that, we need to build our health system to respond to these damage events that already come built in. So my plan for this is to hook into the existing damage system to look at the actor, so whatever we have this attached to, and say, if you take damage, then respond by taking damage here, and then we'll handle all the health tracking and whatnot. This way we can keep our component generic, but we can still use the damage events inside of Unreal. That may not make sense yet, but I think it'll come together in a little bit. So understanding that, let's do a few things and begin play, and then we'll fill out our functions a little bit after. First thing we need to do is we need to get access to our owner. It's almost always a good idea to get your owner and save it anytime you're working inside of a component, because this will allow you to easily get reference to the thing that your component is attached to. So in my health system, I can get the owner, and in this case, it would give us a reference to the first person character, and then we can do other things with that. Like it just gives us so many options. So let's do that first. I'm going to right click in my component, so my health system component, say get owner. And I'm going to right click and promote this as variable, promote the variable, just like this. And this way we're just saving that off. We're getting the owner and we're saving it into a variable so we can easily access it later. Let's rename this, name it to owner. Let's pull it up here, connect it in. So we're going to save our owner, so the thing that this component is attached to. The next thing we're going to do is we're going to set our current health to our max. This is something that I like to do, but you could build a system that doesn't do that. Like you could have a starting health of 50 and a max health of 100, and then you have to like fill up. I think Zelda games do this where you spawn with like 3 hearts or something. You could do it that way, but again, I'm going to keep this simple. So I'm just going to assign my current health to my max. So I'm going to drag my health in, say set health to, drag my max health in to the max. connect it up. Okay, the last thing that I need to do, this is the weird part, and it's not going to make sense at first. But what I want to do is I want to hook into Unreal's existing onTakeAnyDamage event and then respond with my take damage. So to do that, I need to look at the actor that is going to potentially receive a damage event from anything inside the world, which is going to be my first person character. Anything can apply damage to the first person character. I want to listen for that and then respond with my take damage. So to do that, we need to get access to our first person character, or really whatever our owner is on this component. So start watching the owning actor. So we're going to pull off of this. We're going to type in bind event to onTakeAnyDamage. This is saying I want to bind something to happen whenever the owner receives damage and gets this notification. So if anything tries to apply damage to our owner, connect that in, then we will respond because we're about to bind a listening event to this. So we're going to bind something to it that we can use to respond. So this is a little weird since we're working off an existing event right here. Let's pull off and type in create event. And we want to create our own signature to bind into this onTakeAnyDamage. And we're going to select create a matching event. So this is going to run this event in response whenever our owning actor takes any damage. So in this case, it turns out that we don't need that extra function. So I'm going to go over here and delete my take damage that we made earlier. We don't need it. It turns out we can just use our event right here. So let's delete out our existing function, compile, save, and we're going to relabel this to be TookDamage. And now anytime our owning actor takes damage, we will automatically listen and respond with this, and we can do all of our logic here and send out any notifications that we want. Okay, so now let's start to add the functionality for our TookDamage event that responds. Now, the first thing you might be thinking is, why do we even need this event if we're already able to listen to if something took damage? In many games, just because something attempts to damage you doesn't automatically mean you take damage. For example, in Mario, if you collect the invincibility star, things can send damage events to you, but you're not really going to take any damage. So in this case, we want to know the actual time we're taking damage. Another example, some games, when you take damage, you get like a brief invincibility window, like a half second or something. We're not really taking damage while we're temporarily invincible. So this just allows us to add a little buffer or some kind of other exceptions for when we don't really want to take damage. We want to send this notification out when we actually take damage, not just when other things attempt to apply damage to us. But in this case, we're going to keep our initial system simple, but this will allow us to expand into all those additional features that I mentioned later if we want to. So when we take damage, what I'm going to do is I need to take my current health, drag that. Let's get our current health, subtract the damage amount. So pull off of health, subtract, pull in the damage amount, scoot that over a little bit. We want to clamp it to make sure that if we're subtracting health, we're not going below 0. And then we'll also clamp it to our max just in case, even though it shouldn't go up, I guess, unless we apply negative damage or something weird. Anyways, let's just clamp it just to be safe. Pull off, clamp float, minimum is 0, maximum is our max health. And then the result of all this, we're going to set our health to be that. So we calculated it all out, we subtracted it, and let's drag our health in, say set, pull into that, and our return value after our clamp, we will set our new health amount. Let's pull that up a little bit. And the next thing we want to do is actually call our onTookDamage event because we just took damage and we changed our health. So let's notify anything listening to this event dispatcher, this onTookDamage, that this thing happened, and they can respond however they want. We'll look at some examples of this later. So drag this over, and we want to call onTookDamage event dispatcher, meaning this thing happened, notify everything that cares. That is what call means. So we'll say call, plug that in. Here's another cool thing. If you wanted to not only notify other things, but also notify other things in amount or like pass a value in addition to the notification, we can do that too. So if you compile save, let me show you what that looks like. If you click on onTookDamage, our event over here, whenever we notify up at the very top, these inputs, we can pass data through the event and then other things can watch and receive it. So how much damage did you take, for example? So we're going to add a new parameter on onTookDamage, and we can label this. We'll call this amount. Okay, we'll compile say because I've changed the signature of this, I'm going to delete this out and then pull it back in again. We'll say call, Okay, we'll hook this one in. There we go. And the amount that we just took, let's just pull that straight through. This is the amount that we took. So we're notifying other things that we took damage and the amount of damage we took. So if anything watches us, they'll receive this amount whenever it happens. Then the last thing, we're just going to use a print statement just for testing for now. Let's pull off and say print string, and we will print the current amount of health after we subtract it. So see, I dragged in the health over there. Let's print the current amount of health after we subtract it, and we call take damage. Okay, compile, save. And if we want to test this, just a really quick and temporary way to do that, I'm going to come over to my first person character and I'm going to right click. We're going to do a key press. So type in P keyboard. And you'll see we have access to all the keys on our keyboard. I'm going to hit P just for testing. And this is not good to use for like actual in-game logic for controlling things. I just do this kind of thing for testing so I don't have to actually hook in input actions and things. We just want a simple key press that's just temporary. So we have this. And when we press the P key, we're going to apply damage to our first person character. Remember, anything in our scene can do this. We're just faking it, essentially. We're applying damage to ourselves. So when I press key, so on pressed, apply damage. The damaged actor will be self, so pull off and type self. So this first person character is what's taking damage. Compile, save. The amount of damage, let's just put 15 for testing. And weirdly, our damage causer is also self, so we'll just hook that in just in case. Compile, save. So when I press the P key, we will apply 15 damage to ourself. Because our health system is listening to our owner's on take any damage event, it will respond with this, which we will then, when it happens, we'll respond, subtract the health, send our own special on took damage event out that we actually did take damage, and then print it to the console. I think that's a lot, but I think this is just enough that we can start to see how the system will work. Let's minimize and test it out. Hit play. So remember, hit our P key, 85, 70, 55, 40, down to 0. Okay, so we know it's working. And the cool thing is this component still doesn't know anything about the first person character, right? It is just listening to a generic when we take damage on an actor event. As long as you attach this component to an actor or really anything, then we can give it damage, which then we can track and then send out our own events. So one thing you're going to find is anytime you have something in your level that takes damage, you're almost always going to want a sound effect and some kind of visual effect like a particle. And you usually want these to sound different, right? Like when a goblin takes damage, you want that to sound different than when a wall takes damage or something, or your player. So what I'm going to do is I'm going to play a sound effect as part of our component since we're almost always going to do it anyways. But then we are going to expose the actual sound that we're playing so that the designer can very quickly just swap out the different sound associated with this component each time we use it. So if we attach it to a goblin, we'll change the sound out to a goblin damage sound or whatever. So let's put this functionality in. So before we actually send the event outwards, I always like to do all my internal stuff first and then do the event that calls to outward things, because we don't know if something else is going to like kill this object or something in response. So I'm going to do all my effects right here, and then I'm going to open it up outwards. So the first thing I'm going to do is let's play a sound. So play sound at location. All right, let's hook this in. Hook that in. And I'll tell you that you can get whatever placeholder sounds you want. You can look at the ones that come with the starter content or the editor. I already made a few that I'm going to import here. I've done enough other videos showing how to do simple chip tones, placeholder sounds, so I'm not too worried about that. But if you want to know, you can find those. But I'm going to import a player damage sound, and actually just preemptively, I'm also going to import a damaged SFX. Import those two. Drag and drop them in and come in here, Control S, Control S. I'm going to make a sound cue out of each of these. So create cue, enter, Control S. And for my player damage sound, we'll make a cue for that too. Create cue, enter, Control S. Okay, so I imported two different damage sounds. This is what they sound like. Here's the first one, pretty subtle. Here's the second one. Okay, this is my player one. One more thing I'm going to do is I'm going to add a little bit of modulation here so we get some variation in pitch and volume. Modulator. Plug that in. Okay. Okay, just enough variation. Control S. I'm going to do this on my other one as well. You can see how quickly you can prototype things while you're designing. Let's do another modulator here. Okay. Okay, just enough. Control S. And now let's actually play this sound. Let's jump back into our component, health component system. Let's close out our cues, get them out of the way. Okay, play sound at location. We're going to choose whatever sound you have. For me, it's my player damage sound cue. So I get my variation. Pull that over, and the location I want to be the owning actor of this component, right? So remember our owner. So I'm going to drag my owner. So not just my player, just like literally whatever we have this component attached to, that's the location we want. And we get our owner, pull off of that and say get actor location. And this is what we pull off. So since I have this attached to my player character, it will get my player character, since that's the owner, get its actor location and play it right on top of us. Compile, save. Now remember, because this health component is reusable, we don't only want to use this one. We want the designer to be able to swap out a different damage sound for each thing that they attach a health system component on, right? If I click on health system component here, I want to be able to choose this health component damage sound. So we want to make this a variable. Let's expose our sound effect as a variable, right click, promote to variable. And I want to be very clear about what this is. This is a select it, press F2, damaged sound. Okay, compile, save. And anytime you open something up in the details panel so that it could theoretically be none or null, let's actually do a validity check here as well. So I'm going to pull off and say is valid. We'll do the question mark here. And just make sure that we actually assigned a sound, because if it's empty and we try to play it, that might be bad, right? We might get an error. Pull that in. So if our damage sound is valid, then play the damage sound at this location. Pull that down a little. You can see that this green wire all the way over here from damage is getting a little bit in the way. Not a big deal, but maybe we'll fix that later if it becomes a problem. Pull things over. Okay, compile, save. Let's double check our damage sound default. We do have something put in there, but the good thing is now if we click the instance editable, file save. Now, anytime we attach a health system component, if we look over here, the designer can choose their own damage sound for this actor that they attach it to, which is very useful. Let's go and test it out. So if we did this correctly, whenever we apply damage, we'll hear the damage sound for the player. Press P. All right, it's working exactly how we want it to. Now, the next thing I want is, in almost all cases, when something happens in my game, I want a sound and a visual. So we have our sound effect for damage, but we need a visual. Let's create a generic particle burst that will happen for anything that this health system component is attached to, and then we can customize it later with more specific VFX if we want. Let's go to our health system. So this is gonna be very similar to how we played the sound. We're just going to create our effect, play it, check its validity, and expose it to our variable, just like we did with our sound effect. Because we want different things that have this component to decide their own particle burst, for example. So let's create a very generic particle burst. It'll be pretty quick. Let's go down to particles. We probably already have some, but let's make a new one. Let's do Niagara system. Next, we're going to do omnidirectional burst, hit plus, hit finish, call this PS underscore damage burst. Select and control S. Okay, let's open it up. First thing I'm going to do is I'm going to make this red, since that's usually what we expect when we think of damage and being hurt. So we'll do red. Okay, you can see a little preview over here. A little red confetti burst almost. I hit F to kind of zoom in a little bit. Now let's tweak this a little bit. We're not gonna get too fancy because you could always replace this with another tutorial, like your own VFX if you like. I'm gonna go down to spawn count and let's up this a whole lot. So 200 instead of 100. Let's go down to, let's see, lifetime. We're gonna make this a lot quicker. So 0.25 and 0.5. We really want these to shoot out. It's kind of hard to see right here. Now, usually at this point, before I customize too much, let's actually backtrack and go back into here. Let's play it in the game so we can actually see it while we customize. And because this is playing on the player, it's more for other things to see, not like it's not going to look good on ourselves. But when other things are getting damaged, we'll still see this default particle burst and it's going to be more useful then. So we don't want to tweak too much, but we want to see something. Right next to our play sound, we'll try to play a sound first. We'll right click and then say spawn system at location. Okay, so this is asking for a particle system. Let's move this over more. And the one we want is the one we just created, this PS underscore damage burst. The location is again, the owner get actor location. I'm going to control C, control V, paste this. It's over here and we'll plug in our location. So play it right on top of the actor who is taking damage. We do want all the other defaults. So auto destroy, auto activate, all that stuff. And again, we're also going to make this a variable. So right click the system template, promote the variable, call this damage particles. We'll click the eyeball so that each time we use it, we can choose our own on the thing that we attach it to, like over here, just like this. Okay, that's all looking pretty good. Now we also need to check the validity. So I'm going to pull this down here, pull off and say is valid question mark. And we will pull into the execution pin. Is valid. So if it is valid, then we want to play it, because technically we could reassign it to none, or the designer could. Because they don't want any particles to play, we don't want our code to fail, we just want to ignore it. Now, here's another thing that is not quite obvious. Let's actually connect this in as well. If our sound effect fails, like we don't want a sound to play, but we do want the rest of the thing to happen, if our sound is not valid, we don't want to play the sound, but we still do want to continue with the rest of the things in our chain. So I'm going to take my is not valid, I'm going to skip my play sound at location and go straight on to the next one. If that's not valid, we also want to skip and just call the damage. So this is kind of giving us an option where if we don't assign a sound or a particle, it's going to be is not valid. We want to move on to the next step, right? If we don't assign it, we just don't want anything to happen. We don't want to use it. But if it is valid, then we want to. So kind of a little bit weird there. Compile, save. Now that we have this hooked up, let's look at it in game one more time, and then we'll keep customizing. Hit play, hit P. Okay, that's okay. Let's start customizing it a little bit more now. Again, this is going to look a lot better once we see it on something else, but that at least gives us some kind of reference point. I think the next thing I want to do is make them fly out a lot faster. So I'm looking for my velocity down here. So 75. I think the slow ones are fine, but let's shoot them out further. So 1,000 instead of whatever it came with. We're shooting out faster, and I don't want them to be as floaty. So let's go down to gravity force and turn that down to like -200. Okay, I think that's a little bit better. Let's compile, save. And again, this is going to look better on other objects, not from our own camera, but let's try it. Okay, that's fine enough for a generic particle burst that we can replace later. Okay, and the cool thing is anything that takes damage has the option to play these generic sounds and particles, or we can customize them. But you can see it feels a lot better having a sound and a visual while we're testing and for our game feel during gameplay. So P. All right, it really feels like we're taking damage. And the last quick thing I want to do for my effects before I continue is let's clean up a little bit. This is looking a little bit messy. So I think because all this is doing the effects, we can isolate this into a function. So I'm going to select my is valid, all this stuff over here, all the way to my is valid, play sound, is valid, and spawn system. Make sure you have all the stuff underneath it selected too. And I'm going to right click and select collapse to function. Okay, so it's going to put all that underneath the function. Let's give it a name. We'll call this PlayFX. And now we can condense it a whole lot. It's a lot cleaner. Pull it in, zoom in. And now if we want to know anything about playing the effects, we double click, we enter, we check validity, we play our sound, check validity, play our particles. Okay, compile, save. And actually one last little cleanup thing that I think it's worth mentioning, because nothing else should really be able to play the effects. This is all internal. We don't need this to be public. We can actually mark this as private. So let me show you how to do that in case you want to do it. If you go over here, you select it, you change the access specifier. By default, it's on public. We're going to change that to private so that other things can't see it or call it. We really only want to call this internally, which is just on the wrong one. There we go. It's just a better way to encapsulate our functionality without exposing too much. Now we have taken damage and we have printed that and done all of our effects. Let's actually test and see if the damage we just took put us down into 0 health. And if so, then we want to notify that we've been killed. So after my print string over here, we took our damage, we sent out the notification. Let's pull off, say branch. We are testing if our health has gone below or equal to 0. Now, because we're clamping it, it shouldn't be below 0, but we might as well just check it since we're already here in case this gets refactored later or pulled out or something. If our health is ever 0 or below, we want to call that we've been killed because we just took damage. Let's pull in our health. We'll say get health, check. So pull off of that and say if our health is less than or equal to 0, so we'll just keep 0 right there, then this branch is true. Pull that over here, and we have been killed. So all we're going to do is pull our OnKilled event dispatcher, say call. We are notifying things that we have been killed. Now, at this point, you could actually put additional functionality here. Like if you wanted to destroy the actor this was attached on, or if you wanted to do other generic things. But in my case, I don't want to do anything generic when I'm killed. I just want to send the notification out because my player may need to call a special killed event. It doesn't want to be destroyed. It wants to play like a death animation or something. Okay, so for now, we don't really want any generic functionality for our OnKilled, but if we ever did, we could put it right here. For now, we just want to send out the notification that if anything wants to know if this thing has been killed, they can respond and do whatever they want. So let's look at an example of how that would work. Let's say, for example, now that we send out this notification. So let's say that for our first person character, whenever our health system component gives us a notification that we died or that we got killed, then we just want our first person character to destroy. Now we could add death animations and whatever else later if we want. But for now, I just want to show you how you can use a system. So we have our health system component attached and begin play. So I'm going to type in begin play. Now, if you've already been using your begin play, you would just find that and hook off that. But since I haven't, and this health system is attached to this thing, on event begin play, we will pull in our health system component and we're going to pull off of this and watch the event dispatcher that we created earlier, this OnKilled that we're calling. We're going to watch it so that whenever it does get called, we can respond with something. So watch how this works. If we pull off of our health system component, I'm going to type bind event to OnKilled. So this is the one that we made. We also did on TookDamage. We made this one as well, but I'm going to do OnKilled. And so what this means is we want to bind, meaning we want to run something in response when OnKilled gets notified. So when we hit this point over here, we get notified and we respond with something. So let's make a custom event that we can connect into our response event. So I'll create a custom event called add custom event. We'll call this OnKilled. Bind event to OnKilled, and in response, we're just going to connect this. So we just made a new custom event called this thing, pull it over here. And when we get the notification that we got killed, let's do something a little specific just so we know it's working. Print string first person player was killed. And you could play your own special effects here. You could have the game mode respond with something. You can really do whatever you want. And then I'm going to destroy my actor. Okay, and the power of this is that our first person character is watching our health system component, but our health system component doesn't know anything about the first person character or any other thing that you use this on. It's completely generic. It is sending out notifications, but it's not tied to another specific thing, which is exactly what we want. So our first person character is listening to our health system component. When it gets a notification that we were killed, it responds, prints a message, and destroys the actor. You could expand this even further. I just want to show you a simple example. Let's compile and save, hit play, and we're going to press the P button a couple times. So when we hit 0, first person player was killed. We can't control our character anymore because we are dead. And this is just one example of how you could create your own event dispatcher and then bind to it and respond with whatever you want. It's very, very powerful, especially for creating generic functionality. The next thing I want to show you in the system is to prove our modularity. So I want to add my health system to something else in the world and have it behave a little bit differently. So it's always good to test to make sure our components are actually modular before we just consider it done. So what I'm going to do is let's make some damageable furniture. So in our starter content down here that I imported when I originally created my project, or you could use anything you want really, as long as you have a mesh. I'm going to go to, let's see, props down here. Let's do a couch. That's fine. Do a couch. Let's put this somewhere in the scene where we can find it behind the player. That's fine. Hidden damageable couch. I want to show you something. If I hit play by default, see how my projectiles pass through it? Like they're not really registering. A lot of times when you import a mesh, you may not have collision on it. So if your mesh is this way, let me just show you. These ones are. If you open up your couch, you can come up here and under show, if you go to simple collision and you turn that on, you can see that there is no default simple collision on here. So what I want to do is I can either create and export my own with this model, or you can just create some simple one inside of Unreal. So let me show you how to do that really quick. There's a lot of ways you can do this. You could just apply a box like that. That would be fine. I'm going to undo that. Or you can go to auto convex collision. This is a pretty good middle ground. Once you press that, you actually have to hit the apply button down here. So apply. You could also tweak that if you want. You can see it's a little bit complex, but it's just enough to get what we want. So should mostly align with the collision, enough that the player wouldn't really notice. So once you're sure that you have collision on the mesh, Control S to save. I think it's worth pointing out that if you wanted to tweak this, you could select one, select some part of it and move it around. I'm gonna undo that. I don't really need to do that, but I just want to show you that you could. So we have a mesh with collision. Let's make a new blueprint with that mesh. Let's come up here. That was our SM_couch. Let's come over here under our blueprints and let's make a new blueprint class. Actor, it's just a thing in the world. We'll call this damageable couch. Control S to save. Open it up. We're going to add our static mesh component that we just set up. So add static mesh. Okay, static mesh. And then we want our static mesh over here to be our couch. Just have to remember what it was called, SM_couch. That was the one we set up. Double check it's all the same. Whatever it is that you're using, just make sure it has collision attached. Let's also drag our static mesh to be the default scene root. This will just make it easier to move around since it's the only part of this actor that we really care about. Compile, save. Hop back inside of our scene. Okay, now we have so that's our mesh over there. I'm going to delete that out. What we really want is our blueprint, right? Because we're going to do other things to that couch, like make it damageable. Let's drag this back out. Make sure you're dragging out the blueprint one that we just created, not the static mesh, but the blueprint with the static mesh attached. And once we have this, the other thing we need to just verify real quick, if we hop back into the blueprint, make sure static mesh is selected and go down over here under collision presets. You just want to make sure that your projectile or whatever you're using to apply damage, for me, it'll be my projectile. You can apply damage however you want, really, but my projectile is going to apply damage. Just make sure that that is under block right here because we do want it to actually hit the mesh and apply damage. So make sure it's actually registering with the projectile. So projectile on the static mesh. Good. File save. Just want to check this to prevent errors for you all. And the last thing I want to check is I want to check to make sure that my projectile is actually applying damage. So for me, I have my first person blast ball. You could use the default projectile with the first person project if you want, but whatever it is, you need to make sure that on your projectile or your thing that's applying damage, on event hit, just call this apply damage node. It's really easy and quick to do. Connect the thing that is actually damaged for me. Since I'm on the projectile, the other thing it hit, so it'll be the couch or whatever it's applying damage to, that's the other actor. Send in an amount of damage. So for me, it's defined on this projectile. I did this in a previous tutorial, it's 15. My damage causer is this projectile. This projectile caused damage, or you could do something more complicated, like which player shot this projectile or whatever. Anyways, just make sure that whatever your thing is that you want to apply damage, you're actually applying damage. And that's all I really wanted to mention. Compile, save. And now let's go back into our couch, our damageable couch, and we want to give it the functionality to have health and to take damage. So I'm going to go to my components, click add, to show you how quick and easy this is. BP_ health system component. Okay, great. Once that's added, we can customize things. So for example, my damage sound, let's go to the other one I had. I think it was damaged. Instead of player damage sound, it's just damaged SFX_. So we've customized a sound effect. We'll keep our damage burst the same. I think that's fine. And in our event graph, we should be getting the sound effects for damage. Let's actually, let's do one more thing. Let's change the health. Let's put it at, I don't know how much health a couch should have. Say 50. 50 current, 50 max, compile, save. And another thing I want to do is I want to have this couch watch the killed event on its own health system component, and then just print a statement and destroy whenever it gets killed. Again, just to review the concepts we've talked about so far. So on begin play, I'm on my damageable couch. On begin play, let's get our health system component. Let's pull off bind to OnKilled. Let's make a custom event. So right click, custom event, call this OnKilled, connect it. And so now that we're bound, whenever we receive the OnKilled dispatcher notification or call, then let's print string killed the couch and destroy the actor. So hopefully you can see the pattern here, how we can just hook into our events very quickly and easily. And we retained most of the functionality that we spent. We just had to attach the component, maybe customize some variables, and then hook into something if we want. Let's compile, save, and let's test it out. Hit play. Let's get our damageable couch, shoot it. There we go, and it destroys. So you saw the generic particle effects, the sound effects. It was a little different from taking our own damage, right? So this is our own. And I also have some projectile destroying sound effects as well. So it's kind of getting blended into there, but either way, we can customize our generic effects. We could replace them later on with better tutorials. And really, we can put our health on anything we want now. And it's very customizable and open to expansion later if we wanted to add more functionality. Okay, so the last thing I want to do is actually represent my current health on a health bar on our HUD. Always a good idea to let the player know how much of a thing that they have if it's very important. So for me, I already have a player HUD started. So if you don't already have one, you will have to create a new user widget, and you will also have to go over and create it somewhere. So for me, I made this in my first person player. I created my player HUD, assigned it to player HUD, and then added it to the viewport. So I've already done that part. So if you already have in the previous tutorials, great. If not, just make sure you create the widget and you spawn it and add it to viewport. And then after that, we can go in, let's go over here, open up our player HUD. I'm going to add mine to my existing one, my health. So let's add a health bar. This is going to be a progress bar. So let's grab a new progress bar. Progress bar. Drag it down under our canvas panel. Let's relabel this health bar. Okay, it's way up at the top. Let's anchor this in the bottom, the left corner, just like our stamina bar. Pull this down here. We can resize it. So what we can do here is to get our health bar kind of similar to our stamina bar. We don't want to be exact, but let's start off with, let's see, we select our stamina bar, look at 100 and negative 100. Let's go 100 and let's go negative 200 maybe. Yeah, that's fine for now. Let's go to stamina bar. The alignment, we chose 0 and 1. Let's do that one. 0 and 1. This will put the pivot in the bottom left corner. Let's change the size a little bit. Let's make our health bar a bit bigger than our stamina bar. So we'll do 50 size and let's say 400 for our width. A little bit bigger. Let's move our position downwards a little bit. I think there's too much spacing. So something like negative 150 is good. So negative 150 from the corner is where our measurement is coming from. And I think all of this is looking pretty good. So let's customize our health bar. This can be a little different from your stamina bar if you like. You could just copy that and change the color if you want. But if you're creating this for the first time, first, let's go down to our fill color and opacity. We're going to change this to, let's say, a red. I think it's good. Change it to like an orangey red like that. And the reason that you're not seeing this is because right now it's showing the background fill, not our actual fill amount, because we need to turn up the percent. Let's put this at 0.5 just so we can see it. Okay, so this is our actual amount, but our background, we don't really want to be white. That doesn't really look very good. Let's change the tint to our background image up here to pure black and 0.5 opacity. That means it'll be a little bit transparent. Let's go back down to our percent. Let's put that back at 0.5. I think that's a lot better. And actually, I think that'll work for what I need. Compile, save, and now we have our health bar created on our widget. Now, in order to get our health bar functional, we have to tie this percent, this amount of health, to our actual health component. So to do that, we're going to go into our graph over here. You can see we were in a previous binding. So I'm going to go to my event graph. And what I need to do, just like I did over here, is I need to get my player pawn and test if our player pawn has a health component attached, because this player HUD is only looking at player pawns, right? So test our player pawn, see if it has a health system. And if it does, then we're going to save the reference and use it on the HUD. So right click, get player pawn. You're going to see this is going to look very similar to over here. I just want to do it again in case you didn't do the previous tutorial. Pull off of that and say get component by class. Right? We're looking for a component attached to our pawn. So we're looking down here at components. And if we find the health system component, that's the one we're looking for, we want to save it. So back over here, we're looking for component class health system component right there. And let's pull off and say is valid, meaning we did find it. So $1, pull in the execution pin. If we did find it, we're going to pull off of is valid and save it. So let's go down to this return value, right click and say promote the variable, pull that up, is valid. Then we want to set this variable to hold on to it. Let's rename it. So new var is not a good name. Let's call it health component ref. We search for it. If we found it, then it is valid. We save it, we set it, good, compile, save. Now let's go back to our designer view, and we've saved our component reference if we have it. So now we just have to bind our component reference to this bar, check if it's valid, and if it is, then we'll assign our bar amount to our health. So let's go down to our progress percent. On our health bar, once you have that selected, say create binding. It'll open up, come over here. And what we need to do is we need to first check and see if our reference is valid. So pull off, say get, pull off of our component reference, say is valid, question mark. Pull this up, connect it. And so if it's valid, we're going to return, and we need to determine a amount to put between 0 to 1. Now, in order to get a 0 to 1 value, a quick and easy formula for that is our current divided by our max. So think about it this way. If 100 is our max and 100 is our current, 100 divided by 100 is 1. If our current is 50 and our max is 100, if we divide 50 by 100, it's 0.5. If it's 0 as our current and 100 is our max, it's 0. So we're converting our value to 0 to 1 by dividing our current by our max. So we'll pull off get health, which is our current, pull off again, get max health is our max, pull off of health, they divide. So our current health divided by our max will give us a value between 0 to 1. Plug that in. We are now binding our 0 to 1% using our actual health component values. File save. And remember, back in our designer, the reason this will work is because our percent is actually a value between 0 to 1. So this should all be working. We don't need to mess with it anymore. We can compile, save. And I think this should work. Let's hit play. Okay, it's showing up. Great. We're at 100 health. Let's apply damage to ourselves with P. You see how the health bar is responding? It's exactly what we want. And again, we have our other health systems. Great. I have other tutorials for things like damage flashes and whatnot. So you can continue to customize your health systems and damage systems and whatever. But we have player health. We can see it. We can do things with it. And it is very modular. We can test this on many different things in our level if we want. It's reusable and saves us a lot of time without any copy-pasted code. All right, so I wanted to make a little bonus section here at the end to show you a very common use for events, especially inside of UI. Now, right now we are using a binding for our health bar straight to a value. The problem is that runs constantly and it's not cheap. It's not super expensive, but it is running all the time and we don't really need to. Really, we only want to change our health bar and update it when our health changes. So we could create a onValueChanged event and call that inside the health system component. I don't want to go that far yet. For now, I just want to really show you how to hook in and update anytime we take damage. We know that the health bar is going to have to update. So I'll show you a really simple implementation, but you could make this more robust later. So instead of our binding, this is all optional. Like you can keep the binding if it's not a problem for you. I just want to show you another way to do this. I'm going to remove my binding. So on my health bar, remove binding. And instead of tying this value directly to it, we're going to hook into an event and update it whenever we take damage. So let me show you how to do that. I go to my graph over here on my widget. And after we get our health system component and we set it, after we've checked the validity, what I'm going to do is bind to an event on this component. So remember, we have our health component reference right here. Pull off and say bind event to OnTookDamage. So this one right here. So we're binding to this OnTakeDamage event that we created inside of our health system. There's an error here because I need to actually pull in. Now I want to run a function in response. I could have an event over here, but since I've already done that, I want to show you the other way to do it. If you want to run a function, remember our event actually has a signature. It has an amount that it will send us. So we need to run something matching that has the exact same signature. Just a really easy way to do that is pull off and type create event. And in response, I'm going to select function and say, create a matching function. And what this is going to do is going to create a little function over here. It'll auto name it. I don't like this name. I'm going to rename this to OnTookDamage because that's what it is responding to. And it lets me know that it is probably used for an event callback, which is the on part. I like to use that as a little indicator. So we want to take our functionality from our binding and put it inside of here. So let's do that. Let's go to our get health bar percent, which we're not really using anymore. This is for the binding, but I'll keep it here for now. So I'm going to select all of this, copy, take it into OnTookDamage and paste. And so when we take damage, we're going to check validity, In this case, we don't really care about the damage. If we had like pop-up combat text or something, we could display the amount of damage taken, but we want to just update to the current health amount. So we don't really care about the amount of damage. Just because we receive a parameter through an event does not mean that we have to use it. And the last thing I need to do once I've calculated it, just like my binding, I need to set it into the health bar. So I'm going to come over here. I can access my health bar as a component over here. To pull that in. Remember, this is just the health bar widget. So this is this whole thing over here. And I need to go inside of here and access the percent because this is what I'm looking to change. So again, instead of binding, we're just going to set this manually occasionally when we need to change it. So go back to graph and inside of our health bar, access the health bar and say set percent. And we want to change the percent to our 0 to 1 value, which we've already calculated, set it in. If it is valid, then set the percent after we calculate it. So this is doing the same thing as our binding, except we're only doing it when we take damage rather than every single frame. It's a bit more optimized, but I'll show you one other thing that's going to happen here. If I compile save, so if I go into play mode now, you'll notice when I hit play, our health bar looks wrong at first. Technically, we're at full health. That's because we're no longer using the binding, so it's not updating every single frame. We're only going to update it the first time we take damage. So if we press P, take damage, it's proper. But when we initially begin, it's not correct because we are not updating it right when the game begins. So that's one downside to hooking into onTakeDamage is that we're not taking damage at start, right? So we need to actually set the initial start value if we decide to do the non-binding version. So because I'm just setting my health to the max, in my case, it's fine to just set percent to max. So for example, over inside of the HUD, in our event graph, once I bind to the event, I can just take our health bar, get health bar, and set our percent to 1 because I'm just filling it up. Now, if you wanted to have a varying start health, you would have to adjust this. One weird thing is that our health system component may not run its begin play before we run this construct, meaning that if I try to set to the current health, our current health might still be 1 or 0 because we haven't really run our begin play yet. So it's just kind of a weird thing where if you want varying start health, you might want an on value change. That way, anytime the current health changes at all, we'll get an event notification instead of just take damage. Like if we heal, that's not taking damage. We need to make sure we update when we heal as well. I usually end up with an on value change rather than just an on take damage, but we probably want both. I would recommend just setting the start health manually or doing an on value change and call that appropriately, or just set it like I'm doing here to max. But if it's not max, you may need to find a different way to do that. So just remember, I'm just going to leave a comment here, update health bar on start, just so I know later I can update this. So this part's not required, but again, if you wanted it to be a little bit more optimized, you could only respond your UI when it needs to rather than every single frame, right? Like now I really only need to respond when I take damage or when I heal or whatever. See? So just some more efficient way to do it, and I thought I would throw it in here as well as how to hook into functions as well. I mean, in this case, I don't need the health bar percent, but I'll keep it in case I decide to return to the binding. So, but as long as your health bar is working, it's usually fine unless optimization becomes an issue later. Okay, so we are never done with a feature until we have cleaned up after ourselves. So let's do that. Let's go into our blueprint graphs over here. Let's close out things we don't need. So inside of our health system component, you remember this print string? Let's get rid of our print strings. So let's get rid of this one. Our system is working. We don't need to prove it anymore. Let's pull that over, compile, save. So that was one. Another thing we had is inside of our first person character, we had this key for applying damage for testing. We should not leave this in. This was only for building our functionality. Now that it's done, we're going to remove it. Our system actually works now. We don't want to leave our junk placeholder stuff behind us. Otherwise, we're going to forget to remove it later. Let's also remove our first person player was killed. We don't need that either. Plug that in. We're destroying the actor, but if you wanted to do other fancy things like death animations, respawning the player, waiting, doing a screen fade, whatever, you would do it right here. Compile, save. And I think there was one more. Oh, on our damageable couch, let's get rid of this print string as well. Compile, save. And I think that should be it. One final test. We shouldn't see any extra print strings. It should just all work. Should our couch? And we know that we can take damage even though we don't have our button to prove it anymore. But now we can make enemy projectiles or a damage volume or something in our scene, and it should all just work. So this is our reusable health system. It is admittedly pretty simple, but I hope you can see that the way that we built it allows you to add functionality in one place without breaking it everywhere because it's in a component. It's reusable. We can look at events if we want and respond without having to change it for everything all at once. So I think this is a very good and simple system that we can expand on in our future projects.